So in this case, let's say we want to find the area of this sector here. Now, you already know that for you to find the area of this sector, you're going to say the area A is equal to theta over 360 degrees multiplied by pi r squared. This is not new to you. This is something you've been doing. If you're given the angle theta in degrees, you're simply going to divide that by 360, and then you're going to multiply by the area of the entire circle, which is pi r squared. But this is when your theta is in degrees. What about if the unit for this theta here was actually radian? Then how would you find the area of a circle? Because the formulas change when we're dealing with radians. The formulas change a lot when we're dealing with radians. What do we do? Well, the first step here is to convert 360 degrees to radians. That's all. Theta is already in radians. R is just R. Okay? Pi is just pi. Now, from my previous video, we derived the relationship that 1 degree is equal to pi over 180 rad. Okay, so if you want to convert this 360 degrees to radians, we're simply going to multiply it by pi over 180. So our area would then be equal to theta over 360 multiplied by pi over 180, this entire thing multiplied by pi r squared. Okay? This is what would happen. If you simplify this, this is just going to give you 2 pi, because 360 over 180 is 2, and 2 multiplied by pi is just 2 pi. So the area is therefore going to be equal to theta over 2 pi multiplied by pi r squared. It's going to be theta over 2 pi multiplied by pi r squared. This simplifies to 2 pi. The pi's will cancel out because it would be pi over pi, and that would mean that the area is going to be theta r squared over 2, which is equal to a half r squared theta. So the area of the sector would be equal to a half r squared theta. This is a standard formula for calculating the area of a sector, and it's there in your syllabus. Let me show you. And here we are. Use the formula S is equal to r times theta. We already derived that before, and the area is equal to half r squared theta, which is what we have here. The area is equal to half r squared theta, provided that theta is in radians. So when you've been given a situation like this and your angle is in radians, remember, if it's in degrees, you just simply do this. If it's in degrees, you just simply do that. But if your angle theta is in radians, you're going to use the formula half r squared theta, where r is the radius, and then theta is the angle in radians. You're not expected to derive this, but I thought it would be a little bit fun if I just showed you where this came from. Because in class, the teacher's most probably just going to tell you the formula, but is not going to derive it for you. So this video was just to derive the formula for you.